Okay, in this video we're talking about the segment lengths inside of a circle. Excuse me. Now, one thing that pops up a lot that sometimes gets easily overlooked is anytime you're dealing with a problem that has radii, a radius, plural, drawn inside the circle. Remember that all radii have to be the same length. So if you were given that this is 5, that would mean that this radius would also be 5. And that would mean that this radius here would also be 5. So just anytime you're working a problem with that, keep that in mind. So in this type problem, notice that anytime you have that situation, if you were to draw that base right here, you would actually have an isosceles triangle. So everything and all the symmetry involved in isosceles triangles could be applied to these problems. Now, anytime you have two line segments, two chords intersecting inside of a circle, or it could be two secant lines intersecting inside of a circle, then you got 4 line segments created here. What you need to remember about this situation is the product of the pieces of those line segments will have to be the same. What I mean by that is this 3 times this 8, which we know is 24, is going to be the exact same product as this 4 and whatever this missing value is. And that would tell us that obviously we know that missing value would have to be 6 because 3 times 8 gives you 24. 4 times 6 would also give you 24. Anytime the line segments, in this case we have 2 secant lines. And anytime we have the line segments or secant lines in this case intersecting on the outside, the angles on the outside, here's the formula we're going to use. Whole times outside is equal to whole times outside. A lot of times I'll write that as whoa equals whoa. Whole times outside equals whole times outside. What we mean by that, top line segment, the whole thing is equal to 4 and 5, which is 9, times the piece that's on the outside is 4. So we know that that product is 36. Same thing works on the bottom. The whole thing times the part that's on the outside. Now we know that 3 is on the outside, so we know that 3 times something would have to give us that same product, and obviously that number would be 12. So the whole times outside down here would be 3 times 12. So the whole thing would be 12, and if I ask you to find this middle or this inside section, if the whole thing is 12, that would mean that that inside part would be 9. Again, whole times outside equals whole times outside. Also works for when you have tangent lines. Let's focus our attention on the top. The whole thing is 10. The part that's on the outside is also 10. So the whole times outside here would be 10 times 10, which we know is 100. Same thing going on here. The whole times outside, if the whole thing is 20, and we're wanting to know what the outside piece is, since the whole thing is 20, we know the whole times outside would have to be 100. So that means that outside piece would have to be 5 because 20 times 5 is what gives you 100. If I were to ask you for the inside piece, if the whole thing's 20, by segment addition, we would know that the inside piece would be 15. Anytime you have 2 tangents, now these are pretty simple problems. You could go through that long process. If I were to tell you this was 6, we know whole times outside would be 36, but that'd be kind of silly to do because the whole times outside down here would have to be the same thing. The only way that can happen is if it's also 6. What you need to remember is anytime you have 2 tangents drawn to a point of tangency of that circle, that those 2 tangents will always have to be the exact same length. A lot of times I'll call it a clown hat because it looks kind of like a hat, like a birthday cap or something like that drawn on the top of a person. Anytime you have that, the 2 sides of that will be the exact same size.